All right, let's take a look at section 1.1, part 2. Okay, so just a reminder, when we look at numerical descriptions, a parameter is tied to population and a statistic is tied to sample. So again, the way I remember that is parameter goes with population. Both of those start with a P. So the letter P with the letter P, and then statistic goes with sample. And so the letter S with the letter S. Let's look at an example. This problem asks us to determine whether each number describes a population parameter or a sample statistic. So this first one, number 1, it says a survey of several hundred collegiate student athletes in the United States. So as soon as we see that word survey, we can be pretty sure it's a sample. We have to still read carefully, but usually you cannot survey the whole population. So we know this is a sample because we didn't talk to every collegiate student athlete. We only talked to several hundred of them. And we found that during the season of their sport, the average time spent on athletics by student athletes is 50 hours per week. All right, so since we know that we only talked to several hundred, we know that we have a sample, and because of that, we know that the 50 hours a week that we found is going to be a sample statistic. That's my solution down near the bottom. Okay, because it's a sample, I'm going to have a statistic. The S's go together. All right, for number 2, it says the freshman class at a university has an average SAT math score of 514. So that means they looked at every single freshman at that university. So that is going to be a population. And because of that, this math score of 514 is going to be a parameter. So it's a population parameter because we looked at every freshman at that university. All right, number 3, in a random check. Okay, so a random check, just like randomly selected, means that we have a sample. In a random check of several hundred retail stores, the Food and Drug Administration found that 34% of the stores were not storing fish at the proper temperature. Okay, so this is a sample because of that random check. Now remember, your flashcards are going to help you with this. I put some examples on there of words that you're going to watch for. Like the statistics is all about reading. We have to read these problems really carefully and grab our keywords out of there. So since this is a sample, then the 34% of the stores that were not storing fish at a proper temperature is going to be a sample statistic. Put the S's together and the P's together. All right, this problem says determine whether the underlying numerical value is a parameter or a statistic. Okay, so a poll of all, that all tells you it's a population, of all 2,000 students in a high school found that 94% of its students owned a cell phone. Okay, so all tells us it's a population, so we know it has to be a parameter, but you notice they give you a few answers, so you have to read really careful. The first one says a parameter because the data set of a sample of students is a sample. Okay, that word doesn't even make sense. And sample doesn't go with parameter. So A is no good. We know it's not a statistic. If we come down here to F, parameter because the data set of all students in a high school is a population. Okay, that sounds good. Let's try the next one. G, parameter because the data set of a sample. No, as soon as we see that word sample, it's a no-go. Parameter because the data set of all 2,000 students is a sample. Nope, that doesn't work. So the answer is going to be F. This problem again wants us to find whether the given value is a statistic or a parameter. A sample of seniors is selected, and it is found that 45% own a television. Well, they already told us it was a sample. So since it's a sample, that means we want a statistic. So that 45% is a statistic. Let's see, the second So we don't want the first one because that's parameter. The second one says a statistic because the value is a numerical measurement describing a characteristic of a sample. That sounds pretty good. The third one says a statistic because the value is a numerical measurement describing a characteristic of a population. Nope, that doesn't work. We don't want a population with statistic, and then the last one's parameter. So we already knew because it's a sample that it's going to be a sample statistic. Okay, so we have a couple different branches of statistics. Now, most of this you are not going to be memorizing. It is important that you know all about the population and the sample because we're going to use it the whole semester, but we don't want you actually memorizing any of this. A descriptive statistics is the branch of statistics that involves the organization, summarization, and display of data. All right, so that's where we're just presenting data. We're not making any decisions about it. We're just showing you. So that's like all of this data right now as we go through this interesting time in our country. There's all kinds of data being thrown around in the news. That's just straight data that's coming out, and you get to decide what you want to think about that. Displayed in lots of different ways, sometimes graphs, sometimes charts, sometimes just a paragraph with percents inside. And then an inferential statistics is the branch of statistics that involves using a sample to draw conclusions about the population. Okay, so we're going to be learning more about that as we go along, but that's called inferential statistics. So that's when we can't talk to everybody. So we are going to pick a sample and then we're going to try to make a decision. So that's like polling. Right now, we're getting ready for an election. When they run these polls, they can't talk to everyone because for me, I hang up on them. I don't want to talk to them. So they only talk to a sample of people, and then they try to decide based on that sample what's going to happen. Okay, so we have a study here of 2,560 US adults, and they were looking at adults who do not use the internet, and they looked at household income. So 23% are from households earning less than $30,000 annually. So these are US adults who do not use the internet by household income. And so here's our chart. Now, there could be a lot of other things going on. This could be a lot of the older people who don't want to use the internet. Or it could be like my mom. My mom just turned 80, and boy, she can do anything on the internet. She's awesome. She's doing all these meetings remotely with her doctors. Anyway, okay, let's go on. So we want to know the population and the sample. Okay, well, the population is going to be all US adults, but we only talked to 2,560 of them. We know there's millions of adults, right? So the population is all the US adults. The sample consists of 2,560 of the adults that we talk to. So that's our sample. Let's see. The descriptive branch of the statistics is that those percents, right? The percents tell us, because that comes right from the people. Those people we talked to, they told us their household income. They told us if they used the internet or not. So those are facts that came from those 2,560 adults. Now, at that point, we could infer things. I already inferred by saying maybe that was a lot of the older people. It could be that people with that income can't afford internet, although these days, that's not true. It used to be that way. These days, not so bad to have the internet. It could be that you live too far out in the country and it's hard to get internet. So that's where the inference comes in. That's where you're trying to figure out why those numbers look the way they are. Okay, the second one is a study of 300 Wall Street analysts. Okay, so there's a lot more Wall Street analysts than that. So we know this is a sample. Found that the percentage who incorrectly forecasted high-tech earnings in a recent year was 44%. Ouch. So there's tons of forecasters, Wall Street analysts, and that would be our population if we could talk to all of them. The sample is just the 300 that we did talk to. That 44% is a sample statistic because it came from a sample. That is just straight data. That's from talking to 300 of them. That's the percent who incorrectly forecasted the high-tech earnings. And then an inference could be that it's really tough to forecast those high-tech earnings, or maybe we didn't spread our study out well enough. Maybe we talked to 300 people, but most of them were from one company. We didn't spread out. Statistics is very complicated. You have to, as you'll see as we go along, I'm not trying to scare you, but you have to make sure that you have your study set up properly. All right, one more slide for 1.1. So suppose a survey of 573 women in the United States found that more than 55% are the primary investor in their household. Now, we don't know what that means, investor, that they're actually investing money in the stock market or that they're invested in their household. We're not sure, but we'll go with it. So because it says a survey of 573 women, we know that that's a sample, right? Because there's way more, there's millions of women in the United States. So that's a sample. What part of the survey represents the descriptive branch of the statistics? So that would be the 55%, right? That's what we found when we talked to these women. That's the data that came out. And so that is the descriptive statistic. Then we want to look at the inference. So it says there is an association between US women and being the primary investor. Okay, well, based on that data, looks like it because 55% of them were the primary investor. The second one, 573 women were surveyed. Well, that's not an inference. That actually was true. That's the data. And that was our sample. There is an association between the 573 women and being the primary investor. That's actually the data. That's a true statement. That's not trying to make an inference about the population. And then finally, the 55%, that's actually the data too. So the answer would be A.